Okay, today we're going to talk about domain and range continuous functions. So we're going to determine the domain and range of a linear function in mathematical problems. So from graphs, we're going to determine reasonable domain and range values for real-world situation, your word problems, for both continuous and discrete. We talked about discrete last week. That was when our graphs were scatter plots, and that's because we were counting our x values. We're also going to represent domain and range using inequalities. We use inequalities with a continuous domain, and we're going to talk about that now. So recalling from last week when we talked about discrete domain and range, D for domain, I for inputs, X for X values, I for independent. So Dixie is the way that you can remember all of those words for X. And domain is of a relation is the set of all inputs or X coordinates. So it's just you making a list of all your X values. R, range, O, outputs, Y values, D, dependent. So I gave you that word roid to help you remember all the words that mean Y values. And remember, the range of a relation is the set of all outputs or Y coordinates. So you're just making a list of all your Y values. But this week, we are talking about continuous. So what is a continuous domain? It's a set of input values. So you're talking about X values that consist of every number in an interval. So last week we were leaving out numbers. This week we will not be leaving out numbers. We're going to list every number from start to finish. So what does a continuous graph look like? It's a line or a curve. Continuous is connected, equals connected. So if your dots, your points are connected, there is no gap, then you have a continuous domain. That means you do not pick up your pencil to make the graph. If I'm tracing this line, I would not pick up my pencil to get from one point to another, and then the arrow means I'm going to go on forever. This is a quantity that you can measure. So this is how you get a continuous domain. You look at your X values, if you can measure them, and usually you are going to need a tool or a device to do so, then you have a continuous domain. Some common examples of continuous domain: time. Time is always going to be an X value. And what are some things that we measure time with? Well, a clock, a watch, a timer, if it's a race or an experiment like in science. Temperature, we use the tool of a thermometer to measure temperature. And distance, we use several tools: rulers, yardsticks. In cars, they use an odometer to measure the mileage on your car to tell you how many miles you have gone. So you're going to need a tool or a device to measure these things, because we cannot count all the place values in time, temperature, and distance from one starting point to an ending point. If your graph is continuous, meaning you are measuring your X values and you have a connected graph or curve line, then you are going to be using inequalities. We will not make a list because, again, there are so many numbers in that interval that we cannot list them all. It's too long, which is why we're using inequalities. So let's look at some examples of how do I find domain and range. But first, we've got to review our open and closed points. So if you have an open point, that means no bar. So you will be using your less than or your greater than sign. And what an open point means, it means that the number, the X value or Y value at that open point is not going to be included if we were making a list. Here we go. We have a closed point. And that means has a bar on the inequality sign. So we're looking at less than or equal to or greater than or equal to. If it's a closed point, that domain or that range value, that X value or Y value, is going to be included. It's in the list if you are making one. All right, so now let's look at the graphs. So the first example I'm going to give you is I'm going to look at a graph with two endpoints. So when you are talking about domain, there are going to be two questions you need to ask yourself. The first question is, how far left? And the second question is going to be, how far right? It does not matter what your graph picture looks like. If it is connected, those are the two questions you are going to answer and ask yourself to find out your domain. So I am going to go left and right because those are the directions that your x-axis goes. It goes left and right, and I want to make sure I'm reading the values off the x-axis. So I'm going to start here and I'm going to go how far left. I want to go as far left as I can until I reach the end of my graph. So can I stop here and draw a boundary line? No, because I still have graph. So I'm going to go to -4 and I'm going to make a left boundary here because that's as far left as my graph is drawn. It is not drawn any further to the left. So now I'm going to write my inequality. I'm going to say x and I'm going to put -4, and now I need to decide, is it greater than or less than? Well, if I look at my boundary line, is my picture drawn on the right side or on the left side of this boundary line? And if you said right, if I go to the right, that means I'm going in the greater than direction. So at this boundary line, my picture is drawn where the x's are greater than -4. But now I need to look up here. I need to look at my open and closed. A solid line is the same as a closed point, so I need to add a bar to my inequality sign. So I have x is greater than or equal to -4. Now I'm going to ask myself the second question, how far to the right? So I'm going to draw my boundary line. As far right as I go, do I go as far right as 2 or can I keep going? Hopefully you said keep going, and then I'm going to stop at 3 and I'm going to draw a boundary line. Remember, you should not have any graph drawn past your boundary line. If you do, you have not gone as far left or as far right as possible. And we're going to do the same thing. We're going to write an inequality, and we want to use x because x has domain, is another word for domain. And we went as far left as 3, and now I want to look just at this boundary line. Is my picture on the right side of the boundary line or the left side of the boundary line? And if you said left, left is going in the less than direction. And now I need to look at my boundary point. Is this an open or closed point? And since you see a ring, it is not solid and filled in. It is an open, so we need no bar. So I'm going to leave it as a less than. And now I'm going to write both of these inequalities and combine them into one answer, one final answer for domain. So here is how you write your answer for domain when you have two inequalities because you have two boundary lines. What you're going to do is you're going to take the smaller number, -4, and you're going to switch the order. So I'm going to swap -4 and x. When you swap the sides or switch the order, you also have to flip the sign, less than or equal to. Now I want to write this, and if you notice, I already have the x written, so I do not swap the second inequality. It is going to stay in the same order, and since I already have x, I'm just going to copy down less than 3. So my domain is -4 is less than or equal to x is less than 3. What does that mean? That means that any and every value, x value, let's specify, x value between -4 and 3, but not 3, is used. So if I was going to make a list of all of the x values, I would start at -4, and then I would write every x value possible all the way up until 3. But I would not include 3 because its number is not included in my list. Now, if you wanted to make out that list, that would be an infinite number of values because you have to include all the decimals, all the place values between your whole numbers, which is infinitely long, which is why we don't make a list because there's too many. We use an interval notation with inequalities. All right, let's look at one endpoint, one arrow. So this is going to be a little bit differently than how we looked at it when we had a start and a stop. So again, I'm going to ask myself the two questions. How far left? So I'm going to go to the left on the x-axis, and at the same time I'm going to the left on my graph, and you can see I am running into an arrow. An arrow tells me that my graph is going to keep going and not stop. If I keep going to the left, that means I'm going to eventually approach negative infinity. That's just going forever in the negative direction. So since I don't have an exact number for infinity, I cannot draw a boundary line. So now I'm going to ask myself, how far right? So I'm going to go to the right. Again, I'm going to the right on my graph line and right on the x-axis. And as far right I can go is 4. That is where my graph stops going to the right. And since I draw a boundary line, because I have an exact stopping point to the right, I'm going to write an inequality. So x for domain, I stopped at 4, and now I need to figure out, is it greater than or less than? Well, if I look at this boundary line, is my graph picture drawn on the right side of the line or the left side? It's drawn on the left. So if I go in the left direction, that's the same as traveling in the less than direction. And now I just need to figure out, should I have a bar or no bar? Well, if I look at my boundary point, it is a closed point, which means I need to have a bar. So this is going to be a less than or equal to. Okay, so now I need to look at both of my inequalities to write my domain. Well, I only have one inequality. This inequality is my domain, and because I only have one, I will not switch the order. It will stay in the exact same order as I wrote it above the boundary line. So my domain for this graph is x is less than or equal to 4. What does that mean? That means any and every x value less than or equal to 4 is used. So if I was making a list, I could start with 4 and I could write every number that I could think of all the way to negative infinity, and all of those numbers, all those decimal place values would be included in my list. I would also include 4 because it can be equal to 4. Now again, the reason why we're not making a list is because those are way too many numbers to list out. So we're going to simplify it, and we're going to use interval notation with inequalities to represent all of those numbers. All right, next, we're going to look at what happens when you have a graph with no endpoints and you have 2 arrows. So if you notice, your graph picture is drawn on kind of a slant. So when I go down to create this down slant, I'm really traveling in 2 directions. I'm traveling to the left, while at the same time I'm traveling down. That's what's causing the angle of this line on this end over here. Over here, to get it to slant or angle up, I have to travel not only up, but I'm also traveling to the right. And the reason why I want to make that distinction is because when I go to answer these 2 questions, I want to know, am I going left, am I going right? I'm not so much concerned with up and down because, again, the x-axis does not travel up and down. It only travels left and travels right. So now we're going to start answering the questions. How far to the left? So if I go to the left on my graph and on the x-axis, I run into an arrow. And that arrow is telling me I'm going left forever. I'm not going to stop, so I'm going to approach negative infinity. And I cannot draw a boundary because I do not know the exact value of negative infinity. So now I'm going to ask myself, how far right? So I'm going to go to the right, and as I travel right on the x-axis, I'm going to travel right on my graph, and I run into an arrow. And that arrow tells me I'm going forever in the right direction, which means I am going to travel to positive infinity. And because I do not know the exact value of infinity, I cannot draw a boundary line. And if you use every x value going to negative infinity and every x value going to positive infinity, your domain will be all real numbers. Another way that you can see all real numbers written is the double R or the bolded R, the symbol for all real numbers. You saw this R symbol when you talked about the real number system last year in 8th grade and 7th grade math. What does this mean? This means that every x value is used. you are not leaving out any number on the number line. That includes 0. Every number from negative infinity to positive infinity, any number you can think of, any negative, positive number, any whole number, any fraction or decimal, all of those x values will be included in the list. Now again, this is why we use inequality interval notation to list these out or to write this list, because again, there are too many numbers to list out. In the next video, we will look at how do you find the range.